Hello everyone. We are looking at phase 3 complex number exercise 1. We are at question number 5 today. And if you look at the question is x is given as a plus b, y is given as a alpha plus b beta, and z is a beta plus b alpha, where alpha and beta are complex cube roots of unity. And we have to show this expression x by z is equal to a cube plus b cube. Okay. So first thing first, for the familiarity itself, we are going to just write alpha, let alpha as omega and beta as omega square. It is always convenient because we are so used to cube root of unity. So I feel it will help us in our calculation. And just a recall of the properties of cube root of unity. Omega cube is equal to 1. Omega is equal to omega square, and 1 plus omega square is equal to 1. And then let us approach the question. So if x, y, z, we have to find out. So it is a plus b into a omega plus b omega square into a omega square plus b omega, right? So first thing first, we are going to look at this first. Yeah, we'll look at this first. So what is it? Just multiply 1 by 1. So a into, so it will be a squared omega cube, then plus ab omega square, and then plus ab omega to the power 4, and then plus b square omega cube. I think this should be telling us where we are heading. So a plus b into, we know this is nothing but omega square. This is, sorry, omega square is equal to 1. So we are getting a square here, b square here, plus if we take ab common, then we get omega square, and omega 4 is nothing but omega. Now from this expression, sorry, not 1, 0. From this expression, we get omega plus omega square is nothing but minus 1. So this RHS then becomes a plus b into a square plus b square minus ab. Now, this is a very standard algebraic identity. We know this is equal to a cube plus b cube. So I think that's how we can approach. It does not really matter what alpha and beta is, because once we use alpha beta, we always have to remember that it is omega and omega square. So I feel it is better that we replace it, and then we can go ahead because we are familiar with alpha and beta. Thank you.